Higher studies in Japan. 20 research topic ideas in mathematical sciences for MEXT graduate and other scholarship applications for 2026-2027. Konnichiwa minasan. Hello friends, how are you doing? In this video, I am going to give you ideas of 20 research topics in the field of mathematics or mathematical sciences as they call it there in Japan for admission to PG courses in Japanese universities in 2026 and 2027 intakes. Ideally, friends, you should be selecting your own topic and you should be developing your own research proposal. However, it has been observed that many students struggle with writing research plan, research proposal, and even more the selection of the research topic has been a challenge for many. So to help such applicants, such students, I am providing research topic ideas in each field which are tailored to Japan, that is, which is very, very important if you want a scholarship from either MEXT or any private foundation, that your research topic should align with the interests of Japan. So here are 20 research topics in mathematics for Japanese university postgraduate admissions. Number 1. Mathematical modeling of earthquake propagation in Japan's seismic zones. Japan lies on the Pacific Ring of Fire, making it highly vulnerable to earthquakes. This research should focus on developing advanced mathematical models using partial differential equations or PDEs and numerical methods to simulate seismic wave propagation in Japan's crustal structure. The project will integrate data from the Japan Meteorological Agency (JMA) to improve prediction accuracy and optimize disaster preparedness systems. Number 2. Stochastic processes in tsunami prediction and early warning systems. Given Japan's frequent experience with tsunamis, this research will apply stochastic modeling and Markov processes to better predict tsunami arrival times and wave heights. By incorporating uncertainty quantification and real-time data assimilation, the study will enhance Japan's coastal safety systems and contribute to minimizing risks for densely populated coastal areas. The third topic, optimizing urban traffic networks in Tokyo using graph theory. Japan's megacities, especially Tokyo, face complex urban traffic challenges. This research should use graph theory, network optimization, and combinatorial mathematics to model traffic flows and design algorithms that minimize congestion. The study will also explore integration with Japan's advanced public transport systems, contributing to smart city initiatives. Number 4. Mathematical cryptography for post-quantum security in Japan's digital infrastructure. With Japan investing in quantum computing research, the threat to classical cryptography is growing. This project should focus on lattice-based and elliptic curve cryptographic schemes, mathematically analyzing their robustness against quantum attacks. The aim is to contribute to Japan's digital security strategy in finance, healthcare, and defense sectors. Number 5. Nonlinear dynamics in typhoon path prediction over Japanese archipelago. Typhoons frequently impact Japan, as you will all know, disrupting transportation and economy. This research should apply nonlinear dynamical systems and chaos theory to improve prediction of typhoon trajectories. By combining differential equations and bifurcation analysis with meteorological data, the project should aim to enhance Japan's disaster management capabilities. Number 6. Mathematical finance models for Japan's aging population and pension systems. Japan's rapidly aging society creates challenges in pension sustainability and financial planning. This research will employ stochastic calculus, actuarial mathematics, and optimization models to analyze pension funds, annuities, and healthcare costs. The goal is to develop robust financial models tailored to Japan's demographic realities. Number 7. Topology and geometry in robotics, applications to Japanese manufacturing. Japan is a global leader in robotics and automation. This study will explore applications of topology and differential geometry in robotic motion planning, path optimization, and collision avoidance. By developing mathematically rigorous frameworks, the research will support Japan's innovation in next generation robotics and smart factories. Number 8. Mathematical epidemiology of infectious diseases in Japan's aging society. When an aging population and high urban density, with an aging population and high urban density, Japan faces unique public health challenges. This research will apply mathematical epidemiology, compartmental models, and stochastic simulations to analyze the spread of diseases like influenza and COVID-19. Special focus will be given to healthcare policies tailored to elderly populations in Japan. Number 9. Wavelet and Fourier analysis for Japanese language speech recognition systems. Japan's artificial intelligence industry increasingly depends on accurate speech recognition for Japanese language applications. This project should apply advanced harmonic analysis techniques such as wavelet and Fourier transforms to improve signal processing in noisy environments. The mathematical framework will be tailored to the unique phonetic and syllabic structure of Japanese speech. Number 10. Mathematical optimization for renewable energy grid integration in Japan. As Japan expands solar and wind energy, optimizing power grid integration is crucial. This research will use convex optimization, integer programming, and network flow models to design efficient energy distribution frameworks. The goal is to strengthen Japan's renewable energy policy by ensuring stable supply while minimizing cost and carbon footprint. Number 11. Mathematical models of volcanic eruptions in Japan's active volcanoes. Japan has over 100 active volcanoes, including the famous Mount Fuji. This project will develop PDE-based fluid dynamics and thermodynamics models of magma movement, coupled with probabilistic eruption forecasting methods, integrating seismic and geochemical monitoring data. The research will help refine Japan's volcanic hazard assessment and early warning systems. Number 12. Optimization of Shinkansen scheduling using operations research. So friends, Shinkansen is nothing but the bullet train of Japan. Japan's Shinkansen network is famous for punctuality and efficiency. This research will apply linear programming, queuing theory, and optimization algorithms to improve high-speed train scheduling under peak demand conditions. The results will support sustainable transport planning and serve as a model for next generation high-speed rail systems and worldwide. Number 13. Fractal geometry in modeling Japan's coastlines for tsunami simulation. Japan's irregular coastlines amplify tsunami impacts. This study will apply fractal geometry and multifractal analysis to model coastal structures more accurately than traditional Euclidean methods. Enhanced coastline representations will improve numerical tsunami simulations and help strengthen coastal defense strategies in vulnerable regions. Number 14. Mathematical analysis of Japanese kanji networks using graph theory. The Japanese writing system, especially kanji, forms a complex network of characters with semantic and phonetic relationships. This project will apply graph theory, spectral analysis, and network clustering to map and analyze kanji interconnections. The research can support educational tools, linguistic studies, and AI-based Japanese language processing. Number 15. Probabilistic risk models for nuclear plant safety in Japan. Japan's nuclear energy infrastructure requires robust safety modeling after the Fukushima accident. This research should apply Bayesian statistics, reliability theory, and stochastic modeling to assess reactor safety risks under uncertain conditions. The project aims to provide mathematically grounded frameworks for Japan's energy policy and safety protocols. Mathematical climate models for cherry blossom bloom forecasting. Cherry blossoms or sakura hold cultural and economic importance in Japan. This study will build predictive models using differential equations, time series analysis, and climate data to estimate bloom dates under changing weather patterns. The outcomes will aid tourism planning and long-term monitoring of climate change impacts on cultural events. Number 17. Game theory applications in Japan's renewable energy policy negotiations. Energy resource allocation in Japan involves government, industries, and local communities. This research will apply game theory, Nash equilibrium concepts, and cooperative bargaining models to study decision making in renewable energy adoption. The mathematical analysis will suggest strategies for achieving consensus in Japan's energy transition. Number 18. Mathematical optimization of fisheries management in Japan. Japan has one of the world's largest fishing industries, but overfishing threatens marine sustainability. This research will apply population dynamics, optimal control theory, and stochastic optimization to balance fishery yields with ecosystem preservation. The project will contribute to Japan's sustainable fisheries policies in line with global SDGs. Number 19. Quantum probability models for Japan's next generation computing systems. Japan is investing heavily in quantum computing and quantum information. This project will develop mathematical frameworks based on quantum probability theory and operator algebras to model quantum algorithms and error correction. The outcomes will support Japan's leadership in quantum technologies for artificial intelligence, finance, and materials science. And last but not the least, number 20, mathematical image processing for Japanese cultural heritage preservation. Japan's temples, shrines, and historical artworks require digital preservation. This research will use mathematical image processing techniques, including wavelet transforms, variational methods, and PDE-based restoration to reconstruct damaged artworks and manuscripts. The project will blend mathematics with cultural heritage preservation, supporting Japan's UNESCO listed sites. So, friends, that's all for today. We discussed 20 highly relevant research topics in mathematical sciences, which any candidate who is willing to apply for a postgraduate degree, either master's or PhD, may select and develop on his own. So this is all about the research topics in mathematics. In the next video, we shall bring 20 more such topics, and the next time it will be physics. So till then, thank you very much for watching this video. Thank you very much for watching this video. Arigato gozaimasu. Mata imasho.